Tonight's problems should be somewhat of a relief to us because instead of coming up with an equation for these word problems, we're given the equation. And these equations can be found in this section of your book within these problems, but I also have them written here. There are two different equations depending if we're talking about problems that involve meters as their units or feet as their units. So make sure that you pick the right equation for the right problem. Okay, in this equation we have three variable terms. We have height, rate, and time. And every single one of these we're going to be given height and rate, and we're solving for time. So let's take a look at an example of one of these problems. When an arrow is shot upward with an initial speed of 34.3 meters per second, when will it be at the height of 49 meters? So again, I'm looking at meters being the unit in this problem. So I want this equation right here. H equals RT minus 4.9 T squared. Now, in this problem, height is 49 meters. And rate is 34.3 meters per second. Now I have an equation with just one variable. I have something squared, so I want to factor to solve it. Again, I'm going to use a zero product property, which means I need one side to be 0. Instead of subtracting 49, I'm actually going to move all my terms this way. I'd like to keep a positive t squared whenever possible. So adding 4.9 t squared to both sides. And then I'm going to subtract 34.3. Don't you worry about this decimal, because the next step I show you is going to solve any problems you have with decimals here. Let's see, we'll write it all out. 4.9 t squared. Now remember, I need to write, oh, this has a t on it. What am I doing? Minus 34t plus 49 equals 0. Now, usually when I factor, I can't factor when there's decimals. So the trick with any of these problems, especially when you have to use this formula with the 4.9, is divide all these terms by 4.9. The book is really nice and gives you numbers that divide nicely with 4.9. So, if I do that, I'm going to factor out a 4.9. I'm going to be left with t squared. This is going to be minus, how many times does 4.9 go into 34.3? I believe it's 7. And 10 here. Look at how nice that turned out. This is now something that's pretty easy for us to factor. Two numbers that multiply to be 10 and add to be negative 7. Negative 2, negative 5. So my solutions to this problem, t equals 2, not t, or 5. So let's go back to the original problem and make sure that these two answers make sense. My answers of 2 and 5. An arrow is being shot upward with an initial speed of 34.3 meters per second. When will it be at the height of 49 meters? So we would say that it's at the height of 49 meters after 2 seconds and after 5 seconds. And this makes sense because the flight that the arrow will take will go up and down. So at one point, like right here, in its flight, it would be at a height of 49 meters. It'll continue to go up until it stops and starts coming back down to Earth. So again, it will be at 49 meters there. So this would happen at 2 seconds. This would happen at 5 seconds. Mitch tossed an apple to Kathy, who was on a balcony 40 feet above him, with an initial speed of 56 feet per second. Kathy missed the apple on the way up, but caught it on its way down. How long was the apple in the air? This problem uses feet per second, so I want to use this second formula with the 16 instead of the 4.9. When I substitute in what I know that the height, Kathy is at 40 feet above him, and the initial speed was 56. So I substitute those in for h and r. What I'm left with is something that is a polynomial that needs to be factored to solve. So then I started collecting my terms all on one side. I added 16 to both sides, got this, subtracted 56 from both sides, and got this. This is my polynomial that I want to factor to solve. Then I made my life easier, that all of these terms are divisible by 8. So this is where I'm at. Before I stopped and said, holy cow, it's not an easy one to factor, I need the box. So let's finish up this problem. I know that 2t squared goes in here, and 5 goes in here. These two numbers multiply to be 10t squared, and add to be negative 7t. The two numbers I'm looking for are negative 5t and negative 2t. I'm going to factor out negative 5 here, a 2t here. These two just have a t in common, and these two just have a negative 1 in common. So, completely factored, my polynomial now looks like this. This gives me solutions of t equals 1 or t equals, and it's going to be positive 5 halves, as we were doing in class with the zero product property. If you're confused how I got 5 halves, go back and watch the 512 zero product property video. In this case, 5 halves is really not as helpful as a fraction as 2.5 would be. So you could grab your calculator and figure out what that is as a mixed number. So my answers here right now are 1 and 2.5. But the question, if we go back to the original, wants to know how long was the apple in the air before Kathy caught it. Now it cannot be both of these answers, because actually what these two answers give us are both of the times that the apple was 40 feet in the air. We want to know when Kathy caught it. Kathy caught it not the first time that it passed her, but then the second time. So for this reason, we really want to use the second one, because the second one is when Kathy caught it. This is when it passed Kathy the first time. This is when Kathy caught it the second time. So our answer to this question is that the apple was in the air for 2.5 seconds.